Alright, so we have our final set of lessons for Chapter 3. We're going to be solving exponential and logarithmic equations using all the properties that we've discussed in the first three sections. Alright, here we go. Alright, so our goal when solving these equations is to set up a one-to-one property. Because if we can have the same base on both sides, then we can say that the exponents must be the same. Or, if you have the same log on both sides, no matter which log it is, we can just say that whatever we're taking the log of has to be the same. So that's our goal, to try and set up a one-to-one property whenever possible. Alright, so here's our first example. We have 2 to the x is equal to 32. My base is 2, so my goal is to somehow turn 32 into something with the base 2. Fortunately, 32 is the same as 2 to the 5th. So now I can say that the bases are the same. Since the bases are the same, the exponents must also be the same, which means x has to equal 5, and I'm done. Alright, I have a similar process here. The first thing we want to do is make sure we don't have any fractions. So I'm going to start by switching up my 1/4. 1/4 is the same as 4 to the negative 1 power. So I'm going to write this as 4 to the negative 1 raised to the x, and that's going to equal 16. I'm going to simplify that left side just by multiplying our exponents together, which gives me 4 to the negative x. And then I can rewrite 16 using a base 4 as 4 squared. Now that I've done that, I can say my bases are the same, which means my exponents must be equal. So I get negative x is equal to 2, and solving this for x tells me that x has to equal negative 2. And if we wanted to, we could then take our exponent and plug it back in to check to make sure that it works. Alright, here we have two natural logs. Again, we want a one-to-one relationship. So the first step is going to be to take this natural log and move it over. We're going to move it over by adding it. So I get the natural log of 3 is equal to the natural log of x plus 24. Since we have a one-to-one relationship, a natural log on both sides, they're going to basically cancel out. And we're left with 3 is equal to x plus 24. We then want to solve for x by subtracting 24 on both sides, and we get negative 21 is equal to x. Alright, it's your turn. So I want you to try and set up a one-to-one relationship with each one of these, and then solve for x. When you're done, come back and check your answer. Alright, so let's see how you did. For the first one, again, we have a fraction, so we can flip that using negative exponents. And we're going to get 7 to the x is equal to 49 to the negative first. I can rewrite 49 as 7 squared, and multiply that squared to the negative first, giving me a negative 2, which means that x has to equal negative 2. Alright, for a second example, we have a fraction again, so I'm going to rewrite 1/2 as 2 to the negative x, and that's going to equal 32, which we discussed earlier is the same as 2 to the 5th. Since my bases are the same, negative x has to equal 2, which means x is equal to negative 2. Alright, for our last example, I'm kind of running out of room, so I'm going to move up here to solve it. We're going to add the natural log of 9 to both sides to get our one-to-one relationship, which gives me the natural log of x is equal to the natural log of 9, which means that x has to equal 9. Alright, there we have it. Alright, it's not always possible to set up a one-to-one relationship, so when that doesn't happen, we're going to use the inverse properties instead, which means somehow I need to get a raised to log base a to happen, because when that does, they'll cancel out, I'm left with just x. Or e to the natural log of x, again, will cancel out because they're inverses. The other way is to take the log of both sides to get something to cancel out, or take the natural log again to get things to cancel out. Alright, so let's go ahead and apply this. I have the natural log, and I know that e is the inverse of the natural log. So the first step is to raise each one of these up using e as our base. And when we do that, e to the natural log of anything is going to cancel out, and we're left with whatever that anything was. In this case, it's the x. So we're going to have x is equal to e to the 6th, and that's it. Right here, instead of a natural log, we have a regular log. Log base 4 of x equals 2. We identify what the base is. In this case, it's 4. And that's what I'm going to use to raise up my log. So I'm trying to make the inverse relationship happen here. But we have to do the one side, we got to do it to the other side. Alright, so noticing that I have my inverse relationship here, they're going to cancel out. I'll be left with just the x. And that equals 4 squared, which you guys do know is 16. Alright, so this time we have an exponential function, and we're going to try and solve for x, which is in our exponent, which means I'm going to take the natural log of both sides, and I'm choosing natural log because natural log and e are natural inverses. If it wasn't e, I'd have to use a regular log with a base. Alright, so again, natural log and e are going to cancel out. Simplify to be 1, we're left with a 2x is equal to the natural log of 4, and solve for x by dividing both sides by 2. So x is going to equal the natural log of 4 divided by 2. And just so we're clear, this is not going to equal the natural log of 2. We have to take the natural log of 4 first and then divide it by 2. So just leave your answer as a fraction. Natural log of 4 over 2. Alright, so here's a case where we don't have e, so we're not going to use natural log. Instead, we're going to use a regular log. And I'm going to identify 3 as my base, which means that's going to be the base for my log. So I have log base 3 of 3 to the 2x is going to equal log base 3 of 9. Alright, so I can do two things here. I can do some simplifying, or I can try and set up a one-to-one relationship. I'm going to go with the one-to-one relationship, and I'm going to rewrite 9 as 3 squared. Alright, so now I have log base 3 of 3 to the 2x is going to equal log base 3 of 3 to the second. So we have the same base for each one, which means our exponents have to be the same. So 2x has to equal 2, which means x has to equal 1. If I didn't want to use my one-to-one relationship, then I could have solved by using inverses. Okay, so we can see that those are the same. They're going to cancel, which means I'd be left with the 2x equals log base 3 of 9. And I know that 9 is the same as 3 squared, so I can rewrite that. Again, we have our inverse relationship here, which means we're going to get left with a 2. And so you can see it doesn't matter how we solve, we're still going to get x is equal to 1. Alright, so now it's your turn. I want you to try and solve these by setting up an inverse relationship, and then try and get x by itself. Okay, hit pause and come back and check and see how you did. Let's just check and see how you guys did. For this first one, since we have a log, we're going to go ahead and raise them up using 7 as our base. This is going to cancel out, and we're going to get x is equal to 7 to the negative third. The second example, I'm just going to go ahead and rewrite, because our base is x, and we can't use inverses because we don't know what the base is. So I'm going to rewrite this as an exponential, which means I'll lose a log, and we get x to the 5th is equal to 243. To finish solving this, we're going to take the 5th root of both sides, which means that x will equal the 5th root of 243. And for our last example, since we have e, we're going to take the natural log of both sides. So we get the natural log of e to the 2x is equal to the natural log of 5. The natural log of e is going to cancel out because they're inverses, which means I get 2x is equal to the natural log of 5, or x is equal to the natural log of 5 divided by 2. And there you have your answers. Now we're going to step this up a little bit. I'm going to give you an equation that you have to try and get the natural log by itself first before you can do inverse relationships or set up a one-to-one. So in this case, we're going to go ahead and subtract 3 on both sides, giving me 2 times the natural log of 8x, is equal to 8. And then I'm going to divide by 2 on both sides to get the natural log of x is equal to 4. And now I can go ahead and do my inverse relationships. So since I have the natural log, I'm going to use e to raise both sides up. The e and natural log are going to cancel out because they're inverses, and I'm left with x is equal to e to the 4th. This one is also going to involve a few steps to try and get the log by itself. So to begin with, I'm going to divide both sides by 4. which gives me log base 10 of x minus 6 is equal to 3. Now I have the log on one side, so I can try and get rid of it by using 10, because that's our base to raise things up. When I do, again, this is going to cancel, so I'll be left with x minus 6 is equal to 10 to the third. And my last step would be to add 6 to both sides. 10 to the third is 1,000, so x is going to be 1,006. Alright, now we have two logs on one side, so we're going to have to go back to what we did with the last section and combine these into a single log before we can move forward to solve it. So since we're adding these two things and we're going to combine them, we'll be multiplying the two values. So I get log base 3 of x times x minus 8, and that's going to equal 2. To get rid of my log, I'm going to use 3, since that's my base, to raise things up. And at the same time, I can also distribute x to my x minus 8. This part's going to cancel, and I'll be left with x squared minus 8x is equal to 9. To solve this, I'm going to subtract 9 on both sides. And then I'm going to factor this. So we're going to get x minus 9 times x plus 1. Which means for my answers, I'm going to get x is equal to 9 and negative 1. Remember though that you can't have a negative value plugged into your log. And if I try and plug this negative 1, and for x I get log base 3 of negative 1, that won't work. So my only answer here is x equals 9. Alright, this is the last example for the chapter. We're going to do something similar here. I'm going to start by combining my natural logs, and since we are subtracting, and we're going to combine them, we'll get a quotient or a division. So I get the natural log of x plus 1 divided by x minus 2 is equal to the natural log of x. I now have a one-to-one relationship because I have a natural log on both sides, so they're basically going to go away. And we get x plus 1 divided by x minus 2 is equal to x. I'm going to go ahead and cross multiply here, which gives me x plus 1 is equal to x squared minus 2x. I'll move everything to one side, subtracting an x and subtracting the 1, which gives me x squared minus 3x minus 1. And then my last step would be to try and factor this. Unfortunately, it's not going to factor, so I would have to move on to doing my quadratic formula. And I'll do that over on the side here. So for my quadratic formula, I'm going to get negative b, which will be 3 plus or minus the square root of b squared minus 4 times a times c. There's a negative 1 there in the end. And we're going to divide that by 2 times a. So this whole thing is going to reduce to 3 plus or minus the square root of 9 plus 4, giving me 13 over 2, and that is your final answer. Alright, so this concludes the chapter. I'm going to go ahead and pass out the review, and you guys can get working on that, finish up some homework, and prepare for your test, which will be on Monday. Good luck!